All right, we're back finishing the A1 or A2 notes. And we're going to start with the properties of radicals. So let's see, if you look at this first one, we have this index number that's n, and then we have an exponent value of m. Pretty much this first property means that it doesn't really matter if you take the exponent first and then do the root. It will be the same as if you were to do the root first and then raise it to the exponent. A little example is, say that you had, you're taking the cube root of x squared. What you could do is square x first, then take the cube root, or you could take the cube root first and then square it second. It should end up being the same thing. This next one, if you have two radicals and they have the same index, so they have to have the same index. For example, let's do the fourth root of x and the fourth root of y. If you're multiplying these two radicals and they have the same index, what you can do is combine the two numbers underneath one radical that has the same index as what's in the problem. Okay. So this would just be the fourth root of xy. Same goes for division. This actually really comes in handy if you're simplifying fractions with radicals. Normally, I think it's easier to go from the combined radical and split it up into two separate parts. But, you know, you can look at it as either side since it's an equation. The case here, though, is that you need to have the same radical. Here's a little example. I'm just going to do it off to the side here. If you had the square root of 2x over y squared, what you could do is split it apart so that you're doing the square root of 2x over the square root of y squared. The square root of y squared is just y, so this simplified would just be the square root of 2x over y. So there's a little example of that in motion. This one you actually are going to use on homework number 99. Anytime you have a double root, all you need to do is multiply the index values. For example, if you were taking the third root of the square root of, how about, I don't know, x. It's the same thing as taking this, let's see, 3 times 2 is 6. 6 root of x. Okay. Number 5 is actually really the same thing as number 1, but in this case, you might notice that the index value and the exponent are the same. If that's ever the case, just like it was right here, the exponent and radical reverse each other or cancel out with each other. For example, if you're taking the fifth root of x to the fifth, the root and the exponent cancel, and you'll just be left with x. Right? You'll also maybe see it like this. If you were to take square root of 2 times the square root of 2, since it's kind of like the square root of 2 squared, it's just going to be 2. For this next one, what you need to know, if you're taking, let's see, it's actually piggybacking on number 5. If you have an even index value and you're going to take the radical of that value, so for example, if we had the square root of 2, negative 3 squared, your answer is going to be positive. Here, if we have that same problem, but instead we were doing the cube root, so our index is now odd, your answer will be negative. This next part we're going to skip, and I'm going to, you can maybe pause the video to write these down, but there's going to be 3 qualities of simplifying your radicals. The first one is going to be that all your factors are going to be taken out of the radical. This is going to go back to that prime factorization that we talked about in the last section. Part 2, make sure that no radical is in the denominator. In order to get the radicals out, we're going to have to use the conjugate to rationalize the denominator. And then part 3 is just to reduce the exponent, and that's going to be the last part of the notes. All right. So pretty much, you guys have done factor trees before, and I think that's a pretty common way of reducing your radicals. For example, let's see, if we have the square root of 75 x to the third, what we can do is take the square root of 75, which is 75, and just start writing it as a factor tree. For example, 75 is the same thing as 15 times 5, and 15 is the same thing as 5 times 3. Since we are taking the square root, our index is 2. What that means is that for every 2 values, you can take out 1. So here we have 2 factors of 5, so we can take 1 outside of the radical. X to the third is really just x times x times x. For every 2, you can take 1 outside of the radical, and then any leftovers are going to stay inside of the radical itself. So since 3 and x were both left over, you can leave it inside the radical. Part B actually uses some of the properties that we talked about above. What I would maybe do is split apart the radical first, so that you're taking the square root of 32, a to the fourth, and then do that separate from the square root of b squared, leaving you with the b on the bottom. Maybe off to the side, if you think about 32a to the fourth, 32 is 16 and 2, it's even. 16 is 4 and 4. There's the pair right there. A to the fourth, that's 2 pairs, so we can take out 2 a's. And then left on the inside is going to be a 2. All right, moving on. This last part goes along with the whole you can't have a radical on the bottom. In order to get rid of the radicals on the bottom of your denominators, what you're going to do is use the conjugate. So pretend that we have a radical. With your denominator, I'm just going to call it a denom, of a plus the square root of b. If that's the case, if you're going to use the conjugate, what you're going to do is it's going to be the same 2 numbers, except for you're going to have a different sign. The conjugate. Be a minus the square root of b. Okay. Again, this is to get a radical-free denominator. So the first thing that you're going to do is kind of look at this and evaluate if it's simplified or not. Here it has a radical in the bottom, so we got to get rid of it. What's going to end up happening is that you are going to end up with a foiling problem. And they're really going to foil out to be kind of similar each time. And what I'm going to show you, in order to get rid of this radical, what you need to do is multiply the top and bottom by that conjugate. So if you guys remember what the conjugate is, it's going to be the same numbers with a different symbol in between. So this is going to be 3 minus the square root of 7. On the bottom, this is going to be a foiling problem. It's first, outside, inside, last. If you want to, off on the side, you can go ahead and foil it. If you know your foiling properties pretty well, you might notice that this is, I guess, the case where you have the same numbers, opposite symbols. The middle terms will cancel out. So really you just end up with the first term and the last term squared. I'm going to FOIL it out just this one time. So this is going to be 9 minus 3 square root 7 plus 3 square root 7. Again, the square root of 7 times the square root of 7 is just 7, and then it's negative because of that negative sign. Here's the case where they cancel out, so those are gone, leaving you with 9 minus 7, which is 2. On the top, I would just recommend multiplying across and not distributing the number until the very end, because oftentimes with the ways these are set up, it might cancel. For example, now you can see that there's a 2 on the top and on the bottom. Those cancel out. So this, after you rationalize, is just equal to 3 minus the square root of 7. Okay. Excellent. This one right here, it doesn't matter that the radical's first. It doesn't matter that there's a 2 in front of it. We're still going to use the same idea as the conjugate up here. So the conjugate is going to be 2 square root 10 plus 5. Using the pattern over here where you just end up with the first number squared minus the second number squared, I'm going to use that to kind of quickly do this next problem, or next denominator when I multiply them. Let's see. 2 times 2 is 4, times 10 is 40, and 5 times 5 is 25. And then on the top, I'm just going to multiply across, but don't distribute the 5 yet. Going from there, 40 minus 25 is 15. And you can finally just start reducing the fraction. 5 goes into 15 3 different times. So to finalize your problem, you're going to have 2 square root 10 plus 5, and you actually don't need the parentheses, over 3. It doesn't hurt that they're there, but it doesn't really change it at all. Okay. The easiest kind are the ones that really just have the radical by itself with no other operation in the bottom. This is kind of a silly problem because 2 goes into 18. So if you wanted to, you could go ahead and reduce that from the beginning. So that you get 9 over the square root of 2. To rationalize this, you don't necessarily need to use the conjugate as formally as you did up here. Really, you just need to multiply by the square root of 2, or whatever that square root is on the top and the bottom, leaving you with 9 root 2 over 2. Excellent. All right, so this last part is just really about reducing the index. Just make sure that you note, here's a good little visual. Here's the radical with your index n and your exponent of m. You can rewrite that so that it's just an exponent, where m is going to be the numerator of the exponent and n is going to be the denominator. For example, I guess we can just go on to the next part. For example, here my index is 6, the exponent is 3. You can rewrite it so that it's x to the 3 over 6, and then reduce it so that it is x to the 1/2. If you want to finish it out so that it's back in radical form, the 2 can come out as your index, and this would just be x to the 1st. And also, since it is the square root, you could just leave it without an index. Okay. You can kind of see some cases where this comes in handy. I'm actually going to let you try part B on your own. This next one, make sure that with the negative exponent that you take it to the happier place. So this is going to drop down and become a to the 3/2 in the basement. And I want you to go ahead and try and do this one on your own too. It's actually going to involve using the rationalizing. Okay, so that gets you started. Go ahead and finish that one as well.